Hello everyone, welcome to JeremiahKitPlugAtVideoTutor.com. Today I'm going to take you through the introduction of time series analysis using Rstudio. If you have any queries or comment, please drop down them on JeremiahKitPlugAt16@gmail.com. Now I'm going to open my Rstudio on the lower margin of my computer. Now as the Rstudio windows open, we have to be patient. I'll take some cup of coffee if you never mind. Now it has opened. Here is we have the console window down here. This is where our output it appears after we did the output to appear on the console window. We have the window whereby we'll be writing our commands, and we have the environment window where our data will appear, and also we have the part where our post will appear. Ladies and gentlemen, as I have coded, I'm going to take you through this command. I'm going to load a data called M in my computer. I'm going to load my data in my computer. This is how we load it. We write the name of the data of which we want it to be called, and then we read .csv. Reading .csv, take out to the directory in the computer. Now my data is located in a folder called Excel. The folder is called Excel, and then the data itself, sorry for that mistake, so the data is called Excel. The folder is Excel. Now this Excel is located on the notes based on my desktop. Now on my desktop I'll have to find notes, and there on the notes on the desktop I'll find my Excel on the desktop, and then after you open it, my name, the name of my data is X. Then I've opened it, and then when I need to view my data, I will just write M, and then I run the command, and this is our data. Our data is captured from 1st January 2013 to December 2018. Now I'll have to load a forecast library called forecast. Forecast library is the one that we use to do prediction towards the future. And then after I load it, and then we'll have to see the structure of this data. How is this data structured? And then when you load the up down, you will see the structure of our data. This is our data. It is structured as monthly, and then on the Y it is captured monthly, and then the name of the data is diabetes mellitus and hypertension patients. And then we'll have to convert this our data, since is class by now, since our data class of this data M by now is data frame. Type class M data frame, and then you run the command. Since it is in form of data frame now, as you can see down there, the class of our data, see the form of data frame. Hey, Jesus Christ, what the hell is this? It's in form of data frame. Then we'll have to convert this our data type into time series by giving it a new name here, and then we assign the TS command. The TS command is indicate that you are converting our data into time series. And then we'll have the frequency of 12, which it appears monthly for 12 months in a year, and then it will start from the day it started, and the data we captured it from 1st January 2013. And then when I run that, and I come and run the class of this data that I've just converted in time series, you'll find it is TS. Now the class of our data here, it is TS. It is TS since we have converted it into time series. The data has been converted into time series, so the class it is TS. So since our data now it is time series, yeah, we are good to go. This indicates that this our data has learned and follow the trend of time series data. And then we'll have to see it, when did it start, and you'll see it, we captured our data started on 23rd 2013 first, sorry, and then it ends on 2018 December. And then we'll have to see the frequency. It occurs monthly for 12 months per year, and then some is not. We have to test if there is any missing data. Now there's no any missing data since what the result is 0. We have to see the summary of this itself. You have to see its summary, and this summary you have the minimum of 104 and the first quartile 144, median 180, mean 182, and third quartile, and then the maximum of 302. Then we have to load this day by ggplot, which is very compatible for drawing. Then we have to plot the structure of our data to see how the data appears. And you can see here, this how our data appears here. You see, we have this vaccine, the type, this data that is still stationary. We have to do something to actually this data is unstationary. We have to do something to make it stationary, but you can see there is unstationarity in this data because you can see the trend. And then we have to draw the line in between this data, and then this one we draw the line. You can see there is a trend, there is a pattern. Actually, you have the increasing trend in this data since 2013 to 2019. This trend of this original data indicates that there is no any stationarity. And then if you have to see the time of this the circle, you see this data comes from January to December. This is the times it occurs, 12 years. 12 times, that is monthly. Here we have to see the cycle in which month it appears. You can see the circle, it appears from January to December, from 2013 to 2018. Then we have to find the aggregate. We have to find the mean mark. We can see how our data flow. Now this is the flow of our data. It comes from 2013. You see the original trend. This original trend. It is an increasing trend, and then we have to check the seasonality through drawing of the box plot. You can see the box plot of this data. We have to check the seasonality as an indicator of seasonality. We see the box plot, and when we see a box plot closely, we see that in the month of July and October, there is relatively increment in the sales of these vaccines of diabetes mellitus. Then we have to make it stationary by homogenizing this mean. You see, we have to homogenize the variance to make the data stationary, and by homogenizing the variance, it will only be stationary when we talk the log value of the variance, so that the data is stationary. And now voila, the data is stationary. Now for our prediction, we have to load another library function called the t-series. T-series is the one that we use to prediction of time series. Now we have to draw the ACF augmented autocorrelation function and partial autocorrelation function to check and determine the value of ARIMA model. ARIMA model is the value that we'll use to predict our ARIMA model is the best parsimonial model that we'll use to predict our study for the next few years or so. Now we have to plot auto.arima to give us the best fit. The best fit, now we will find that the best fit ARIMA model here, the best model of ARIMA is 100110012 with the drift. This is an indicator that this data actually it has been introduced from auto regression integrated moving average to ARMA, autocorrelative moving average, which means there's no any integration, and our data just been reduced to stationary. Then we have to fit this model so that you can predict the pattern for the next 10 years. And then we fit the model, and after we fit our model, we have to find this value of fit. This is the fit, we have the call function of the fit, and then we have to predict it for the next 10 years. We do this prediction for the next 10 years, and let's predict. We will see that after the next 10 years, this data is what? It has the log function. We have to eliminate this log function to find what? The real numbers. That is by doing we do the round off of this predictor. by 2.178. We raise to predict and